everyone. Today we're going to talk about the sine rule, so let's get into it. So the sine rule is mainly used for solving non-right triangles, although it can also be used to solve right triangles. We're going to focus on non-right triangles this unit. So looking at the diagram, first of all, remembering that we usually denote angles with capital letters and their corresponding sides with lowercase letters. So angle A is with a capital A versus the side across from it, lowercase a is the side. When you look at the sine rule, you might see it two different ways. One where they have the sides across the top and one where they have the angles across the top. The formula booklet gives you the first option, so just so you know. But you might also, if you look at YouTube videos or something, they might show you the other version. They both mean the same thing, it's just flipping it. One important thing to note, though, is while there's three different things equal to each other here, we're only going to use two pieces at a time. So we might only use the A and B information, or we might only use the B and C information, or just the A and C information. It depends on the triangle. So let's get into an example so you can see what I'm talking about. In example 1, we have angle A. Wow. Example 1, we have angle B is 20 degrees, angle C is 31 degrees, and side B is 210. And we're looking to find side A with that information. So first and foremost, I'm going to draw a triangle just so I can see what we're looking at. All right, so I have my triangle. Angle B is 20 degrees, angle C is 31 degrees, and side B is 210. Note that your triangle doesn't have to look like mine. It does not have to be to scale, right? It's just so that we can put an image in our heads. We're eventually, or in this problem, looking for side A. So that means that thinking about the sine rule from the previous page, if I'm looking for side A, I have to have angle A in order to find it. You have to have at least half of that fraction. So luckily, I'm given two of the three angles in my triangle, so I can just do 180 minus 20 minus 31, and I can find that angle A is 129 degrees. So that's piece 1. If you're missing the angle opposite of the side you're looking for, find that first. Next step is I'm looking at the information I'm given. So if you notice that I am given angle B and side B, and that's key. You're usually given or can easily find one of those pieces in the sine rule. So if I look back to my previous page, I'm usually given one of these three fractions in full, or I can easily find it just like I did, like I just found angle A. So I'm given the B information, check. I'm looking for A, so that means I'm using those two pieces of this sine rule. All right, so just rewriting the pieces I'm using, you don't have to, but it can help the first few times you use this. And then filling in what I know. I'm obviously looking for side A. I know that angle A is 129, so I'm doing sine of 129. Side B is 210. And angle B is 20 degrees, so doing the sine of 20 in the denominator. And then a lot of these are the same kind of process. You're going to cross multiply and isolate the variable you're looking for. All right, so I've cross multiplied, and I'm going to go ahead and isolate A further by dividing by the sine of 20. This is really just to prevent us from rounding prematurely, so that I don't type that numerator in my calculator and then round and then divide by sine of 20. Just prevents any of that from possibly happening. So in my calculator or in Desmos, what I'm going to type in is this large fraction on the right-hand side. Don't forget that if you're in Desmos especially, make sure you change to degree mode. We're still using degree mode here because they give us the angles in degrees. And when I do that and I round to 3 sig figs, I'm getting 477. We weren't given units for the side at all, so that's just my answer. All right, example 2. In triangle QRS, I'm assuming it's a triangle since that's what we're talking about. QR is 15 meters, SR is 6.5 meters, and angle S is 125 degrees. And we're finding angle Q. I know it's angle Q because it's an uppercase Q. So again, let's draw a triangle real quick just to see what we're looking at. All right, so QR is 15 meters. SR is 6.5. and angle S is 125 degrees. And we're eventually looking for angle Q down here at the bottom left in my diagram. So again, convenient, or not convenient, but it's on purpose that I am looking for angle Q, and I also have side Q. So I know that's key. I also, if I look at the rest of the information I'm given, I am given angle S and side S. So even though these are different letters than what's in the formula booklet, the key is that you're using connecting information, as in a side with the angle across from it, and I'm looking for an angle with the side across from it. That's what you're looking for. So let's try to do this one without first writing the formula, because ABCs aren't going to help me in this one anyway. So thinking about what I'm looking for, I have the side 6.5. I'm looking for the angle across from it. So I need that divided by the sine of Q. Always divided by the sine of the angle, sine of the angle. That's going to be set equal to the side, the other side that I have, 15, divided by the angle I was given, which is 125, the sine of the angle I was given. Same deal, I'm going to cross multiply and try to isolate my variable. All right, so when I go to isolate my variable here, notice that we're finding an angle. So sine of Q is going to have to stay put for a second, but I can at least divide by that 15. Remembering back to right triangle trig, when I'm looking for an angle, I'm going to have to use the inverse sine in this case to find that angle. So when I go to my calculator, whatever I get from this fraction on the right-hand side, I'm going to have to do inverse sine of that decimal that I get. Or if you want to combat possible issues with just finding that fraction or finding that decimal and leaving it, go ahead and isolate Q now by doing the inverse sine of that fraction on the right-hand side. That way, it's already going to be in your calculator. You don't have to worry about doing it as a second step. So when I do the inverse sine of that very large fraction, either in my calculator or in Desmos, to three significant figures, I get that Q is 20.8 degrees. All right, example 3, the angles of elevation to the top of the mountain are measured from two beacons, A, where the angle of elevation is 29.7, and B, where it's 41.2. And both of those beacons are at C. A is the more distant beacon, and the beacons are 1,473 meters apart. We're looking for the height of that mountain, or how tall is the mountain. So there's a lot to unpack here, so let's start just drawing a picture. I know that these beacons are at C. Right? I also know that beacon A is the furthest, and then there's B, and they are looking at angles of elevation to the top of a mountain. So what that means is from A to the top of the mountain, its angle of elevation was 29.7. From B to the top of the mountain, its angle of elevation is 41.2 degrees. I also know that these two beacons are 1,473 meters apart. That's this distance between A and B. End goal, as if we don't have enough going on in this picture already, but our end goal is to find the height of the mountain. So what that tells me is at some point, I am going to need to use this height and therefore this right angle, right? So that height with either part B or beacon B, where I use this angle of 41.2, and I'll have to have either this distance on the bottom or the distance from B to the top of the mountain. So that's option 1, or an option. Another option would be still looking at that height. Oh, let's do a different color. So still looking at that height, but going all the way to A instead. So looking at this larger right triangle instead. Both are going to be the same amount of work. It's really just a matter of which one you see and which one you'd rather do, but they're both going to be the same amount of work, and they're both actually going to use the same beginning triangle, which is, if you notice, we only have this distance between A and B. So what I'm going to look at first for either of them is this smaller triangle from A to B to the top of the mountain. So not using the height yet, and that's okay. This is definitely a two-stepper problem. So I'm going to take that triangle out of the craziness of this diagram just so we can focus on the pieces we need. All right, so I got my orange triangle. I know the distance between A and B is 1473. I know angle A down here was the 29.7 degrees. And I know this angle B, in this case, the outside of my triangle is 41.2, so over here. But supplementary angles tells me that I can just do 180 minus the 41.2 to get something within the triangle that I'm focusing on to get this obtuse angle B over here. Which if I do 180 minus that 41.2, I'm going to get, and I'm just going to write it on the outside so I have space, 138.8 degrees. All right, so I'm going to go through the whole problem looking for, we said our first option, which I was talking about, this smaller red triangle, which is harder to see now. So I'm going to go through the whole problem looking for that, which I'm going to call this missing side that we're going to look for first A, and then I'll do the whole problem again where we'll use B instead, just to show you both options. All right, so looking for A first. Obviously, I have angle A, which is helpful since I'm looking for side A. And the only side I actually have is between A and B. I'm going to call that side C, or at least the angle across from it, I'm going to call angle C. So luckily, I have the other two angles. So I can again just do 180 minus the 138.8 minus the 29.7 and get angle C as 11.5 degrees. So now I have angle C and side C, check, because remember you need one piece of that puzzle for the sine rule. And I'm looking for angle A and I'm looking for side A and I have angle A. So let's write in our equation. I'm going to skip writing the formula piece and just go right into subbing in what I have. So looking at my C information, just because that's the one piece of the puzzle that I have fully, I have side C of 1473 divided by sine of angle C, which is 11.5, equaling my A information. So I'm looking for side A divided by the sine of angle A, which is 29.7. Same deal as example 1 and example 2. I'll cross multiply, isolate my variable, and then go to my calculator. Right, so I isolated my variable, my side A, and I got it to be 3,660.62. I'm not rounding to 3 sig figs yet because this is not my final answer. I can now use that piece, again, thinking about that smaller red triangle, which I'll again take out so that it's more clear to see what we're looking at. I know this is my height, and that's what I'm looking for, so that's why I can stick that 90-degree angle in there. I now know that this distance is 3,660. And I know that this angle down here was that original angle given to me from beacon B, which was 41.2. So at this point, it's your choice. You can still use sine rule if you want to. You have an angle and the side across from it, and you have an angle and you're looking for the side across from it. So you can definitely still use the sine rule, even though it's a right triangle. Or if you want to, you can revert to right triangle trig using SOHCAHTOA, one of those to find your missing side as well. So if I were to do that using SOHCAHTOA, I am looking for my opposite and I have my hypotenuse. So that means I'll use sine of that angle equaling my opposite divided by my hypotenuse. And then just like we were doing with right triangle trig, I can stick this sine of 41.2 over 1, cross multiply, and solve for my height. So after I cross multiplied and I plug this in my calculator, I get 2,411 meters, just rounded to the nearest whole meter. Or if we wanted to do 3 sig figs, I could say 2,410 meters. Either way, as long as it's at least 3 significant figures, we're good to go. All right. So that's how you would do it finding side A. I'm going to repeat all what's in red, but I'm going to try to find this side B instead, or this distance from A to C instead, to use that bigger pink triangle. All right, so option 2, looking for this longer distance from A to C, we're still going to need that angle C, so I left that in there. But now we're going to try to find this distance. I'm going to call it B, since it's opposite of angle B. So same kind of idea, that I would still use the C information, 1473, divided by the sine of 11.5 degrees. But this time I would use the B information. So I'm looking for side B divided by the sine of 138.8 degrees. Same deal, cross multiply, isolate your angle, or isolate your variable, and use your calculator to solve for it. And when I plug this big fraction in my calculator, I get 4,866.628. Again, not rounding a whole lot, or trying not to round a whole lot, because it's not my final answer. Using that value, and again, refocusing on this large pink right triangle, I'm going to redraw it out here. Not perfect, but that's okay. Looking for my height, I have my angle down here as my original A's angle of elevation of 29.7 degrees. I now have this long distance from beacon A to the top of the mountain, which is 4866.628. And again, still looking for my height. So it's set up the exact same way as when we did it with A, with that red triangle. It's just that now we have different numbers, but it's still going to be the same setup. So again, it's really just a matter of what did you see first, once you unpacked the question, and just which one stood out to you more, really. It doesn't matter which way. Don't feel like you have to write in both. It's just a matter of which one makes the most sense to you. But they get solved the same way, which is why I'm talking over what I'm writing. It's just different numbers. So this time I would sub this, or type this into my calculator. And again, I'd still get my same height of 22,411 meters, or to 3 sig figs, 2,410.